Okay, so in this section, we're into part 2. We're going to go over environmental, dietary, and lifestyle risk factors that impact longevity. Academic goals is review the literature regarding environmental, dietary, and lifestyle factors that impact longevity. And the clinical objectives understand how diet, lifestyle, and environmental risk factors play a clinical role in longevity and chronic disease, and how to implement those into your practice. So ultimately, when you look at lifestyle, dietary, and clinical interventions, you're looking at some interventions that directly activate longevity genes, like the sirtuins and mTOR and APK. And you're also looking at activating genes that indirectly prevent pathophysiology of aging. And fundamentally, the things with lifestyle that impact longevity, epigenetics, are things that impact hormesis, right? The ability for us to respond to different stressors. And, we gave the example of earlier in the introduction of the course, a situation where you have, let's say, male or female, and they have excessive caloric intake, sedentary lifestyle, lack of cognitive stimulation, sterile environment. There's really no hormesis. There's nothing that's really stressing their physiology. If you compare that to someone who's got limited caloric intake, athletic lifestyle, intellectual challenges, ongoing environmental microbiome exposure, they're going to have a completely different outcome of aging. So up here, the person has excessive caloric intake. They're going to basically promote, protein aggregation. They're going to promote inflammation. They're going to promote inflammaging. They're going to turn off their longevity genes. The sedentary lifestyle is going to do all the same things. Lack of cognition stimulation. They're just not going to develop plasticity, connectivity. They're not going to impact neurogenesis. Everything here is showing that they're not going to develop mitochondria. Sterile environment means they're not going to develop any kind of microbiome resiliency and pathogen resiliency. And here, like if you have someone who's like, let's say doing time restricted feeding and then working out, and maybe the common thing would be like they wake up, they have coffee, extend breakfast for a period of time, have an 18 hour fast, they go work out during that period. They then are doing some intellectual challenging tasks, and then they like to go for hikes and get in an environment and get exposed to microbes and other things unintentionally. They're going to have a completely different outcome. So the ultimate mechanism of lifestyle and dietary things that impact hormesis are things that put challenge or stress to the system, and as challenge and stress is put to the system, like free radical challenge or caloric restriction or microbiome pathogen challenge, or emotional challenge, physical challenge, toxin challenge, thermal challenge, that doesn't cause adverse reactions but just stresses out the system. Then when people develop mitochondrial biogenesis and autophagy, turn on the antioxidant system, get into anabolic shifts, right? And then you really want to make sure the other thing you consider with lifestyle is hormesis challenges that do not lead to adverse reaction, increasing resiliency. So you always want to, in your clinical workup, we're going to go into identifying what the resiliency levels are and then trying to find things to improve it at a rate that doesn't cause any kind of injury. And then for some people, their resiliency in different pathways may be restricted to some degree for a long-term basis. And you just want to still work within those limits, but still get some activity in for whichever those pathways you want to turn on are. So these are the main topics we're going to discuss here and go through the literature. And we'll apply these to clinical applications throughout the course. So exercise, muscle mass and strength, body mass index, diet, tobacco use, alcohol use, environmental toxins, polypharmacy, social relationships, and sense of purpose. These are each independent variables that will have a huge impact on the expression of the hallmarks of aging and then turning on longevity genes that offer us protection. So exercise is the obvious one. We all know it's good for us. And studies are pretty clear. It definitely reduces cardiovascular risk. Some people may not know there's direct links with exercise in literature, in addition to improving cognitive dysfunction and risk, but anxiety and depression, specifically anxiety. Anxiety is one of the most common conditions out there. And when you look at all the different health conditions that people search for help with search engines, anxiety is one of the top ones. And exercise is one of the clearest and easiest ways to change anxiety. And then exercise definitely impacts weight and blood sugar control and lipid metabolism, maintains muscles to be strong, improves cerebellar vestibular innervation, prevent falls, proprioceptive output. And there's also strong evidence that exercise reduces risk for malignancies, prostate cancer, breast cancer, bowel cancer. And, when we get into the mechanism of the hallmarks of aging, it basically does everything you want for every aspect of the hallmarks of aging. Now, when you look at exercise, the question is pretty obvious. It's not should you, the question is how much do you need to, how much is beneficial? Is there, do you need to become a super athlete? Do you need to have a six-pack? Do you need, what's the level of VO2 max, which is related to cardiovascular fitness, you need to have effects? And, what's attainable, what's achievable? Is there any big difference from being a super athlete to not being to just being an average person who works out? So those are the things that we want to discuss in this section. Okay. Now, before we get into the studies, we've got to clarify what a lot of studies use for cardiovascular fitness, which is the VO2 max. Okay. So VO2 max is the gold standard measure for a person's aerobic fitness level. A person's maximum oxygen uptake, VO2 max, refers to the maximal amount of oxygen that an individual can consume typically over 1 minute during an intense physical effort. Aerobic fitness level is strongly and positively related to health, longevity, quality of life, and performance. Now, in a research setting, they'll measure VO2 max on a treadmill, and they'll actually measure their maximum oxygen uptake and get a measurement. But it can be done yourself. If you want to measure your own VO2 max, you do this calculation here, 15.3 times maximum heart rate divided by resting heart rate. Let me just show you a quick video here that just shows you how to do it for yourself.
VO2 is the max pressure of the maximum amount of oxygen your body uses when you exercise. To get a general estimate of your VO2 max, first, take your resting heart rate by placing 2 fingers on the artery between the center of your palm and your thumb. Count the number of beats over 60 seconds. Then, take your maximum heart rate by working out to exhaustion, and then checking your pulse again for 60 seconds. Divide your maximum heart rate by your resting heart rate, then multiply the result by 15.3 to get your VO2 max. For example, if your resting heart rate is 85 beats per minute and your maximum heart rate is 200 beats per minute, you would divide 200 by 85 and get 2.35. Then, you would multiply 2.35 by 15.3 and get 35.9. Therefore, your VO2 max would be 35.9. The higher your score, the more in shape you are. If you want a precise measurement of your VO2 max, contact a sports medicine facility and complete a stress test. There are also fitness trackers, like a Fitbit or Athletic Watch, that you can use to monitor your VO2 max while you work out.
Okay, there's also been a recent study that looked at the accuracy of Fitbands, and they found that they were accurate in the degree enough that it's useful clinically, useful personally, but not so much for research settings. They found that it tend to underestimate, which is good. You want it to underestimate versus overestimate. So they can be used as a way to track VO2 max. Here's just a diagram that goes into VO2 max for physical activities. Like the maximum oxygen required for sleeping is 3, right? And then if you look at, for example, walking, it's up to 11, and then walking at 7 kilometers per hour, 19, and then cycling is 25, and then running, you get way up there in 51, 67, 81 VO2 max requirements at the following, kilometers per hour pace. So, if someone can get to a VO2 max of 51, that's their health, and they can run at this pace, assuming that they can keep it for an hour. Okay. Now let's talk about some of the research published on VO2 max and longevity and mortality. What degree of VO2 max fitness do you need to have for longevity? What does the research show? So this was a paper that was published in JAMA Network. It's called The Association of Cardiorespiratory Fitness with Long-Term Mortality Among Adults Undergoing Exercise and Treadmill Testing. So this was a retrospective study, so they went back. It was a cohort study of 1,222 subjects with a median follow-up of 8.4 years. Consecutive adult patients referred for symptom-limited exercise treadmill testing were stratified by age, sex-matched cardiorespiratory fitness into low fitness, 28 less than the 25 percentile, below average, 25 to 49 percentile, above average, 50 to 74 percentile, and high fitness, 75 to 97 percentile, and then elite, like super athletes, 97.7 percentile. And the conclusion of looking at these different scales of fitness was cardiorespiratory fitness is inversely associated with long-term mortality with no observed upper limit of benefit. Extremely high aerobic fitness was associated with the greatest survival and was associated with benefits of older patients, benefit in older patients and those with hypertension. So if you look at the results, here you can see, VO2 max broken down into these groups that they classify them to low, below average, above average, high, and elite. And if you look, if your cardiovascular fitness is really low, then your survival probability goes down. But if you go to below average, even below average is much better than no exercise and activity. Just think of below average, they're just sedentary, they can't do anything. And they typically want to avoid exercise all the time. But once they get a little bit of activity, their survivability goes dramatically up. And then if they get just a little bit above average, above 50th percentile, there's a dramatic change in their survivability. And then there's no big difference between super elite and high elite athletes. And also if you look at the change in survivability, if you're looking at this ratio, one being, significant, or insignificant. If you look at the actual ratio here, the percentage of change you have of survivability odds from just above average even to high is not that much. So as long as someone's getting any kind of physical activity in, there seems to be protective effects. It's not like unless you're a super athlete, you don't get any cardiovascular protection, okay? So that's the main thing to take away there. And then when you look at this survival performance by VO2 max, for men and women, they were looking at different variables, all participants and by sex. And ultimately, you can see their risk, if you look at adjusting for, this is all-cause mortality, the lowest risk is obviously with the elites and high, but above average is a huge difference between very poor health. So you have to have just some degree of fitness to really make a difference, which is easy for most people to do as soon as they just start working out. Above the average means people can just basically walk at a very slow pace. I think it's, here's the list, for example. When you look at the ranking of average of 1.5 mile running scores. So middle is they're getting through a mile in 12.54 to 19.9 seconds in this age group. So let's say someone's 50. So can they walk at a pace to finish 1.5 miles on a treadmill between 16.4 and 24.8 minutes? If they can, then they're in the above average group. And then if they can do it in less than 16 minutes, they're in the top group. So you can see these are feasible for people to get to have cardiovascular benefits for cardioprotection. Okay. And then when you're looking at principles of exercise intensities, you can look at things also in studies where they not look at the VO2 max, but they classify exercise by light physical activity, which is walking slowly, sitting using a computer, standing in light work, fishing sitting, playing most instruments. Moderate, which is walking very briskly, cleaning heavy, like mopping, shampooing, vacuuming, mowing the lawn, bicycling, light effort, badminton, recreational, tennis doubles. And then if you look at high vigorous activity, hiking, jogging, shoveling, carrying heavy loads. So that's another way you'll see some of this research done on exercise intensities. So when you look at those standards, and look at this paper that was published in Circulation of over 100,000 patients and looking at two cohort databases, they found that the near maximum association with lower mortality was achieved by performing 150 to 300 minutes per week of long-term leisure activity, VPA, and then 360 minutes of long-term leisure activity with mild physical activity, or equivalent to combination of both. So you can see here, look at the all-cause mortality, moderate to vigorous activity. You can see different things. Obviously, the more vigorous they have, the less rate they have of heart disease. But any kind of any kind of activity overall seems to have a linear distribution. So what they're finding is, depending on how you get your minutes in and get your hours in, you can have some different effects on all-cause mortality. This was some of their data. And they found the similar things of working out and getting some activity in. Any kind of fitness that basically improves all-cause mortality. That's kind of the summary of everything. There's a point where, you have small gains when you get to the high elite levels, like the other studies found. Now, you also find research and studies in longevity and exercise with activating telomerase. And if you remember, telomerase is what helps elongate these telomeres, and it slows down telomere attrition. And if you look at these studies, sometimes they get mislabeled with the assumption that exercise lengthens these telomeres. They don't really lengthen them, but they definitely turn on telomerase activity. When you turn on telomerase activity here, what you're basically doing is slowing down the telomere shortening, which then leads to more DNA damage and so forth. So this was a paper that was published in Aging Research Reviews, and they go on to say that exercise training increases telomerase reverse transcriptase gene expression in their title, and telomerase activity. It was a systemic review and meta-analysis of multiple studies. Based on the findings from the identified eligible trials, both a single bout of exercise, and long-term exercise training upregulates telomerase reverse transcriptase and telomerase activity in non-cancerous somatic cells. Endurance athletes also exhibited increased leukocyte TRT and telomerase activity compared to their inactive counterparts. These findings suggest exercise training is an inexpensive lifestyle factor that could increase TRT expression and telomerase activity. Exercise could attenuate, slow down telomere attrition through telomerase-dependent mechanisms, and ultimately extending health span and longevity. So if you're looking at those telomerase testings, where you look at telomere length testings, and a person shows up and they're in the 30th percentile of their telomeres compared to their age, and they haven't done any physical activity or exercise, if they, let's say, get into an exercise program the following year, they measure the telomeres, and now they've gone from the 30th percentile to the 50th percentile unrelated to the length, that's pretty good, right? So you can do what you can with your age. You're not expecting to lengthen them, you're just expecting to turn on these enzymes so you can attenuate further loss. And then hopefully over time, your loss is comparable to the population, to the rest of the population your age, if it was poor before. This is a study that was published, effects of different levels of exercise on telomere length, a systematic review and meta-analysis, 11 studies, almost 20,000 subjects. Compared with inactive individuals, telomere lengths were longer in active subjects, regardless of the intensity of the exercise. So the more active they are, the longer their telomeres, the more protection they have against DNA. The longer the telomeres, the more protection they have against DNA, the less likely they have cancer development and oncogenes and epigenetic effects and all those things associated with senescence and aging. So major mechanism that's important. So any kind of activity doesn't have to be super intense. So if you kind of look at this, you research the changes that people need to do with exercise. Doesn't have to be hardcore, high intensity exercise. It doesn't have to be super athletic type exercise. It just has to be some exercise. And if you look at the requirements of like above average of what time you need to do, let's say for a treadmill to finish 1.5 miles, you can see it's not that difficult. Any basic level of fitness is attainable for most people that are trying to look at exercise for extending their longevity. This was a study that was published. Does exercise affect telomere length? A systematic review, meta-analysis, randomized clinical trials, 7 studies, 939 subjects. Exercise has beneficial effects on telomere length compared with usual care or inactivity. Exercise for more than 6 months is associated with changes in telomere length. The evidence gathered to data show that aerobic exercise slows the decline in telomere length. And this is, again, another example where people read into this the wrong way. They're showing people who are exercising more than 6 months compared to people that aren't have changes in lengths in general when they look at that 6-month window of data. But when you look at the evidence, it's just slowing down the decline in telomere lengths. It's not making telomeres grow again. So that's important to understand. This is another paper, Do Telomeres Adapt to Physiological Stress? Exploring the effects of exercise on telomere length and telomere-related proteins. Numerous studies have implicated telomere protective phenotypes induced by moderate levels of physical activity, indicating an important cellular adaptation that may slow the onset of symptoms or prevent certain age-related diseases. In contrast, several lines of evidence in both immune cells and skeletal muscles indicate that telomeres may actually shorten in response to long-term high-intensity endurance training. As such, the tissue-specific response of telomeres should be investigated with specific consideration given that the proliferative demands placed on the tissue by exercise stimulus and the antioxidant capacity of the individual tissues. And this is where I want to start getting into research that you can have too much exercise and accelerate aging. So even though some studies show like elite athletes that have good VO2 max have effects, it's really borderline with research, and I will admit it's controversial, where there is increased risk for damage and shortened impacts on longevity. This one I just showed you was on telomere length, the people that do have excessive exercise. It's all about hormesis, whether it's exercise or other aspects. And so you look at a quote from Hippocrates 2,500 years ago, and it said, if we could give every individual the right amount of nourishment and exercise, not too little, not too much, we would have found the safest way to health. And when you look at exercise, there's this concept where you can exceed health and function, and this is known as the reverse J curve of exercise. And this is especially with like long distance runners, long distance marathon triathletes, they get excessive training. They actually have some problems that show up, and they can impact their longevity. So wealth of scientific literature backs the unique therapeutic benefits of exercise and quality of life, cardiovascular health and longevity. Consequently, many assume that more exercise is always better. However, chronic excessive endurance exercise might adversely impact cardiovascular health. Ultra endurance races can inflict acute myocardial damage, as evidenced by elevations in troponin, brain neurotropic peptide. Moreover, sudden cardiac arrest may more often are in marathons and triathletes than in short races. Veteran endurance athletes often show abnormal cardiac remodeling with increased risk of myocardial fibrosis and coronary calcifications. Chronic excessive exercise has been consistently associated with increased risk of atrial fibrillation, and along with some attenuation of longevity benefits. The optimal dose of exercise remains unknown and probably differs among individuals. Current studies suggest that 2.5 to 5 hours of moderate to vigorous physical activity will confer maximal benefits per week, right? Per week. Greater than 10 hours per week may reduce these health benefits. And this is like continuous exercise activity. Let's say 2.5 hours per week. That's like 2.5 hours of vigorous cardio. It's not like 2.5 hours of like, some of it is stretching, some of it is weight training. This is like 2.5 hours of like just running, for example. 2 to 5 hours a week, that's okay. But once you get over 10 hours, so you can see the J-shaped curves here. So there's a point, and these are all different studies that were published, the names of the researchers on the bottom, and they just see this J-shaped curve where it's beneficial, harmful, beneficial, harmful, beneficial, harmful. This has been repeated in multiple trials. So VO2 max being improved itself is definitely linked to all-rate mortality, but then that's one indicator. But if someone's exercising the point where they're exercising in a moderate or higher vigorous physical activity for greater than 10 hours per week, they may get into this J-shape where it's actually causing adverse problems for them. Here you can see dose-response association between physical activity and volume and atrial fibrillation. So you can see as they increase physical activity, their atrial fibrillation risk goes up. This was a study that was published, 8 interventional randomized clinical trials called Physical Activity and Telomere Length, the Biomarker of Aging Systematic Review. Taking together physical activity with regular aerobic training of moderate to vigorous intensity appears to preserve telomere length. However, the temporal intensity, duration of physical activity, as well as type of exercise, still needs to be further elucidated. Reducing the amount of sedentary behavior may have a positive effect on preserving and increasing telomere length. So it's really this balance people have to achieve, but definitely increased fitness, VO2 max is ideal, but training to the point of a triathlon or marathon activity greater than 10 hours of increased physical activity can be a problem. So here's a summary schematic of potential impacts of exercise and telomere length. So you see regular exercise increases. You can look at the intensity levels. They have some impact. And then if they get inactivity, you turn on oxidative stress and inflammation, you have this telomere attrition. So this paper titled Emerging Role of Aging Process in Exercise Training and the Crosstalk Between Gut Microbiome Telomere Link was also very interesting. Based on studies summarized in this article, exercise training can increase biodiversity of beneficial microbial species, decrease low-grade inflammation, and improve oxidative metabolism. These factors together possibly reduce telomeric shortening. And that's the thing is exercise does what? Exercise can change different pathways of immune function and metabolic activity that then impact these. And there's some really interesting studies being done with telomere length and exercise itself. This was another paper that was published, Dose-Response Relationship Between Physical Activity and Mortality in Adults with Non-Communicable Diseases, Systemic Review Meta-Analysis of Prospective Observational Studies. And it goes on to show that the study aims to investigate the relationship between post-diagnosis physical activity and mortality in patients with selected non-communicable diseases, including breast cancer, lung cancer, type 2 diabetes, ischemic heart disease, stroke, chronic obstructive pulmonary disease, osteoarthritis, and low back pain, and major depressive disorder. So all the conditions that we talked about. The shape of dose-responsive curves are characterized by no threshold for the beneficial effect of physical activity and mortality, meaning that any physical activity is better than none, and regressive non-linear dose-responsive patterns where the greatest difference in mortality rates occurred during inactive compared with minimally active individuals. There is no minimum dose physical activity for life prolongation. Less physical activity then recommends 105 minutes of a week or less of life expectancy benefits for adults with non-communicable diseases. So the bottom line is you have to get physical activity, and if you overtrain, it's worse. And if your VO2 fitness keeps improving, it's better for you. So you really want to get as much exercise and much cardiovascular fitness as you can to improve your longevity. But once you get to the point you're going for elite status activity, you're not getting any major benefits that are profound. And also, if you have extensive amounts of vigorous activity, then there's this potential for getting a J-ship response where things increase your risk for all-cause mortality. Okay, so that's where the research and exercise is right now in longevity. Also, exercise has been shown to increase mitochondrial health. We've talked about this earlier. Mitochondria in all tissues go up when people do any kind of physical exercise. The more physical exercise you do, the greater mitochondrial biogenesis you get. And remember, when you look at all the different biochemical pathways, every single one of these biochemical pathways requires ATP. We made the example earlier that when you're looking at how important ATP is for recovery, the more potential ATP function, the more potential ATP that can be produced by a person, the greater chance they have to recover from whatever their underlying condition or disease is, the more adaptability they have, the more general resilience they have. So when you look at all the different types of resiliency, they all fundamentally have to do somewhat with ATP production and how cells can function with their energy demands. So exercise, without question, is probably the most effective way to increase mitochondrial biogenesis. And then it does this in all tissues. And then you can be specific, like cognitive activities increase mitochondria in regions. So you could have someone who listens to music all the time and plays music they're a musician. Their mitochondria density in their auditory cortex is going to be much greater than others of the brain compared to other people. So tissue-specific use is going to increase mitochondria, but overall exercise increases activity all over. Okay. So when you look at resiliency overall and a person's energy levels, the more mitochondrial function they have, the greater their benefits. Now, when you exercise, you build mitochondria, and that'll last for a few weeks, let's say 2 to 4 weeks. When you stop exercising, you lose mitochondria. So if you stop exercising for 2 to 4 weeks, even within a 2-week period, you're going to have less energy, less activity. So when people take breaks from working out, maybe they, for whatever reason, stop working out for, let's say, a month, they come back and it's really hard to recover and really hard to do things. And part of the reason is because they don't have enough mitochondria. If they try to do things, they can't do it or get injured trying because of those mitochondrial systems haven't been kicked in place. That's why you say, work slowly, don't exceed yourself. Really what they're saying is rebuild your mitochondria so then you can actually perform those tasks. Okay? Exercise in the aging immune system. So in this paper, they go on to say that aging is associated with decline in normal function of the immune system that is described by the canopy term immunosenescence. This contributes to poorer vaccine responses and increased incidence of infection and malignancy seen in elderly. Regular exercise has been associated with enhanced vaccination responses, lower numbers of exhausted senescent T cells, increased T proliferative capacity, lower secretory levels of inflammatory cytokines, inflammaging, increased neutrophil phagocytic activity, lowered inflammatory response to bacterial challenges, NK cell cytotoxicity, activity, and longer leukocyte telomere lengths in aging humans, all of which indicate that habitual exercise is capable of regulating immune system. So basically, exercise helps protect telomeres, helps against DNA damage, helps build mitochondria, and helps avoid stem cell exhaustion of immune cells called immune senescence. So it really does all the things we want. So when we look at the hallmarks of aging, exercise hits every single one of those. Now, when you look at the SARS, look at the pandemic, there was this paper that was published called SARS-CoV-2 19 and the Aging Immune System. And they try to explain why certain people were dying from COVID-19 or having long COVID, and why some people were more compromised than other people. And obviously the geroscience researchers explained it through the basic concept of geroscience, and this is what they went on to say. Excuse me. The field of geroscience has been given a boost to the attention to COVID-19 pandemic, which will hopefully lead to more advances and breakthroughs in the near future. Indeed, our first defense against any virus is a properly functioning immune system. Thus, we need to further elucidate mechanisms of immunosenescence and pursue the development of therapeutics that will enhance health span in a preemptive way. And they go on to show, for example, factors that impact inflammaging and immune senescence, like environmental industrial toxicants. So when you looked at outcomes in New York and areas in busy cities throughout the world, there were high degrees of mortalities from the viral pandemic, right? And the concept is that these environmental toxins, bad diets, physical inactivities, all the things that impact the hallmarks of aging may lead to immune aging and immune senescence. And you can see here where they looked at immune response patterns with clinically diagnosable mild and severe COVID issues. And they can see a direct relationship between people that were able to recover and not recover, and people that had mild symptoms and not mild symptoms by the efficiency of their immune responsiveness. And those that have immune senescence weren't able to respond and deal with the infection as well. And then those that had inflammaging, those that had a lot of, garbage in their cells, protein, had these exaggerated inflammatory responses, the so-called cytokine storms. So when someone has lots of protein aggregates in their tissues, all this garbaging, all the things causing inflammaging, and they have immune senescent cells, when they get exposed to pathogen, it can cause death, it can cause slowed recovery, and it can cause ongoing problems. So this is the same with any virus. Like when people die from the flu season every year, it's because their aging physiology is off. So it's, again, not always associated with age, but chances are when you're aging, you have greater expression hallmark of aging. But if people, they use the term like, healthy. Well, if you're healthy, you don't have anything going on with the virus. What does it really mean? It means you have all the hallmarks of aging under control. You have plenty of mitochondria, your immune cells are working, you have immune senescence. Those are all critical. So when people start to lose their resiliency, that's when you start to get worried. When people start to lose their resiliency for their microbiome or their immune cells, they have chronic infections and those things, that's when you're worried about these potential patterns. And also as a red flag, like you can have someone, just from people that have had reactions to getting SARS-CoV-2, if you saw them having months and months to recover, that's a really strong indication to have lots of inflammation in their body. It could be one of the things. See someone who had a severe response and a severe inflammation, they couldn't get under control, and they were worried about them, that could really indicate they have some degree of immunosenescence. And like when this happens to young people, you find out they were like drug users, they were, they had some toxic exposures, or there was variables that really impacted their genome stability that caused them to immune age much quicker than other people, and so forth. Okay, so we know exercise helps with immune health. Now, exercise also has been shown to play a huge role in plasticity. Physical activity is a non-invasive, relatively inexpensive strategy that has repeatedly been shown to upregulate hippocampal structural and synaptic plasticity. Numerous preclinical studies have now demonstrated that physical exercise has the potential to mitigate cognitive decline associated with normal aging, as well as neuropathological hallmarks and behavioral abnormalities characterized by various neurological conditions, including those that are prevalent in older populations. So neurodegeneration, brain, you see all the different oxidative inflammatory pathways that place, and the exercise basically reverses all these major pathways. And we went into this in the cognitive decline course in great detail. So any physical activities is useful. So here's the thing, you have to think about it. If you have a patient who's sedentary, you just want them to move. If you have a patient that moves, you want them to exercise, but you can't exceed their threshold. The other key thing when you're looking at aging is when you do exercise, the stronger the VO2 max, the better for longevity. But also you want people to do really cognitive, you want to have people to maybe if they can do it with social tasks. So if they can dance with other people, that impacts another aspect of their resiliency and their overall health. So they have social interactions. They can compete. That can help the social interactions. If they're in a club, that can be a difference. And then also with exercise, like if they can do more coordinated tasks, like their balance is involved, their reflexes are involved, their reaction time is involved. So they're just running, that starts to protect and serve different areas of the brain. So those are the things you want to, consider when you see somebody, let's say, going down the wrong way and trying to develop a treatment plan. Okay. So it goes on to say in this paper, exercise attenuates the major hallmarks of aging, and it goes in and concludes, exercise certainly cannot reverse the aging process, but it does attenuate many of its serious systemic and cellular effects. So again, once you get some degree of senescence and telomere shortening, it's a problem, and you're just trying to maintain what you have. So the sooner, the better. And if people go 5 years, 10 years without any activity, there's some accelerated aging that they will never get back, right? Any kind of short, moderate, any kind of movement or activity, even if they're not super fit, does not matter. Even if they get any kind of movement, really has some long-term protections. Now, this is a great paper, Exercise Attenuates the Major Hallmarks of Aging. And they went through every hallmark of aging, like genomic instability, telomere attrition, epigenetic alteration, loss of proteostasis, dysregulated nutrient sensing, mitochondrial dysfunction, cellular senescence, stem cell exhaustion, alternate cellular communication. And then it showed exactly how exercise specifically impacts each one of these pathways. So every hallmark of aging is impacted by any kind of movement, any kind of physical activity. And in this paper here, they also went through and just explained all the different changes on sirtuins and mTOR pathways and AMK pathways. So if you want to take a deep dive into the specifics of exercise and these longevity expressions and how ultimately it impacts protein biogenesis, mitochondrial biogenesis and autophagy, protein synthesis pathways, antioxidant production pathways, you may want to check that paper out. And this was another paper that was published in Aging, and then it just goes into stress the same things. It supports telomere preservation, telomere length preservation, mitochondrial biogenesis. So it's like the top of the list. It's the absolute top of the list. Physical movement, exercise is going to turn on all these gene expressions, going to have protection. I think what people don't understand is, first of all, somehow people think exercise has to be an hour. So like all exercise classes in a gym are an hour long. Like spin class is an hour. Yoga class is an hour. All these different things are an hour. And that doesn't seem to really matter. If you really look at the benefits of exercise, we look at it per week, they find that they don't have to have daily exercise links that make a difference. So you do 20 minutes one day or 30 minutes another day. As long as you get to the threshold, let's say 150 minutes over a 7-day period, you're getting the benefits of exercise and movement. So obviously moderate and vigorous makes you need less minutes, but just any kind of movement's important. So, I've seen patients that sometimes, for various reasons, get out of sync with it, and they don't realize, you don't need to lose 100 pounds. You don't need to lose 10 pounds. You just need to move. It's just about movement itself. You don't need to have this visual scenario where you have to go to the gym and get into gym lifestyle. You just need any kind of movement. So any kind of movement is going to have long-term protective effects. The problem is some people just get to lack of movement. And that's where things go wrong. At the same time, whatever movement they're doing, if they can increase their VO2 max, they're going to have better longevity effects. They're going to have better expression of the longevity genes. So if you have someone who is struggling with repairing, let's say, their leaky gut and things aren't working, and you're dealing with all these different hallmarks of aging, like autophagy issues, and they have, just some moderate activity, if you can say, hey, can you get your VO2 max up 10%, 20% the next month? That could really turn on their longevity genes and these pathways more so than anything else, right? Than any kind of supplements or anything else. So let's say they go on a treadmill and they, jog a mile and they do it in like 12 minutes. Say, can you get to 10 minutes in the next month? Because it's going to have a huge impact on turning on these expressive genes. So so first of all, if they have no movement, you want to get some movement. But improving the cardiovascular capacity only enhances everything that they do. The only time I'm really worried about is if you start getting into marathon runners, triathlete runners, which typically isn't most people's patient population, right? Those are complete outliers of a different group of people. They're actually a different species. I used to work with Ironman triathletes early part of my career, and they were not like other people in so many different ways. And I don't mean that in a good way. I mean that in a bad way. I mean, of course, they're great people, but just the way they thought, the way they did things, and they had an addiction to exercise that was many times unhealthy, and they didn't care if it impacted their health, just like an alcoholic doesn't care at times. But for most people, the more VO2 max you can get, you can attain, the greater your VO2 max, the greater expression you'll have in all the positive longevity genes, and the reduced expression of aging you will have. That's just the way it is. That's the studies show. Okay, and they also slow down your telomere attrition. Okay. Now, another key thing is muscle mass. So muscle mass is absolutely critical when it comes to aging, especially when someone gets older and you want to avoid frailty. So physically inactive people can lose as much as 3% to 5% of their muscle mass each decade after age 30. And symptoms of sarcopenia are loss of stamina, difficulty performing daily activities, walking slowly, trouble climbing stairs, poor balance and falls, decreased muscle mass size. And, when you look at their MRI of the thigh, you can see that there's all this extra space in between the muscles that have invasion by fat cells. Then you have many people that are VAT. They're not fat, they're VAT. They're normal body weight, but they have lots of visceral adipose tissue. So you see that with as many Asian populations. They have like no muscle mass, and instead of the muscle mass, they have body fat. And those people, as they age, are really prone to sarcopenia patterns as well. So muscle is critical for healthy aging and direct links to mortality. So here you can see a vicious cycle of frailty. So we have malnutrition, disease, environmental issues, chronic undernutrition. This leads to sarcopenia. Sarcopenia is going to impact the ability for them to have strength and power, which is going to impact their walking speed, their physical activity. Their total energy expenditure goes down. And now they're not building mitochondria. Now they're not turning on their longevity genes. Now all these pathways become dysfunctional, and they get stuck in this vicious cycle, right? And here it says undernutrition. So that's a major issue, especially with elderly, especially if they don't get enough protein or just get enough caloric intake. Okay. And this was a paper that was titled "Inactivity of Skeletal Muscles and Metabolism: Vicious Cycle of Old Age," and they really just go on to say, like, this is the vicious cycle. Let's start with here: inactivity, disability, telomeres start to shorten faster. Neurodegeneration starts to take place. They start to have poor diets, anorexia, malabsorption. Hormonal systems start to fail. They get inflammation, mitochondrial dysfunction. They get more and more chronic conditions. They can get excess weight as they're losing muscle mass, and then they're not functioning at all. Now they're in this inflamed pathway with vicious decreased strength. Now, things that impact muscle tone, like testosterone, growth hormone, are really critical. There's a point where people age. Now, in this course, we're not talking a lot about like hormones and anti-aging perspectives of that. But when people lose their organ reserves, you definitely want to consider hormone replacement therapy, especially if they get sarcopenia. Things like testosterone, even things like growth hormone, could be ideal. Now, what we're not getting into in this course, the conversation of should a 25-year-old, 30-year-old take growth hormone and testosterone? That's not our goal this course. Our goal is to talk about longevity, physiology, and what to do. And to be quite honest, with growth hormone and testosterone and being taken by a 30-year-old, it's just really a field of opinions right now and not enough science to it. So if you want to do it, you look for the science that says it's beneficial, and if you're against it, and ultimately for me, in my practice as a clinician, I go, what do you want to do? Where's your perspective? And then kind of decide what the things are. However, if they have sarcopenia and they are eating protein, you definitely need to consider hormones if they haven't been on them to try to get some anabolic activity working for them, especially if they've lost their organ reserves during the aging process. Okay. So in sarcopenia, you actually have fat deposits in the muscle cells. The muscles become much more inflamed. Their ability to regenerate and grow becomes compromised. Protein synthesis in the muscle itself becomes compromised. So it does create a vicious cycle. And the longer they've had it, the more of a vicious cycle feed-forward pathway they get. So it's something you really want to avoid as much as possible. So if you're working with elderly patients or have elderly family members, you really need to immediately take a quick look at their body mass index and their muscles and see if their functions are there. We're going to talk about the sit up and go test, and we're going to talk about like grip strength and so forth. But a lot of times you can just physically see when people are losing strength and just don't have endurance. And that is a major sign that they may have mortality, increased risk from all-cause mortality. So the key difference is people start to get sarcopenia and aging is a lack of skeletal muscle and less mitochondria. The muscle quality is compromised. Now, what's interesting is muscles themselves, they release myokines, proteins. So when people do physical activity and have more muscle mass, there's a series of proteins that are released, like IGF-1, BDNF, even lactate. And these things start impacting signaling pathways, and these things have been shown to keep the brain healthy. So physical activity enhances circulating levels of myokines in the bloodstream, affects brain regulating neural proliferation and differentiation, plasticity, memory, and learning. And we used to just think of like muscle tissue as just mass that contracts. And we used to just think of like body fat as storage of energy. And we know that body fat is highly metabolically active, releases adipocytes, adiponectin, inflammatory cytokines, so it has a huge messenger response with insulin signaling pathways. And myokines seem to have a significant response with anabolic activity, responsiveness, neuroplasticity, and regenerative properties. So you definitely want a person to lose muscle mass. Now, here you see sarcopenic obesity, which means you don't know they have lost muscle mass because their body fat is covering it up. So they don't look frail, right? So here you can see abdominal fat on the outside, outer layers. Then you can see muscles. And if you look at these body shapes, probably visually it's easier to see with the imaging study, they would kind of look like the same body shape. The only problem is, this one doesn't look at the muscle mass. There's even atrophy here. All these muscles are on the abs here compared to the muscle mass here. Look at the back muscles. So this person has serious risk because not only do they have sarcopenia, but they have increased body fat. That's a bad combination. That's the worst combination for all-cause mortality. Okay. And this is just a paper if you had a chance to read on your own. But it just goes into sarcopenic obesity and how all these things impact the mechanism of aging and oxidative stress and inflammation. And the way you change all these things is by physical exercise. And the muscles themselves release myokines. These are different myokines that go down when you stop moving. These are myokines that go up when you exercise. And then these myokines have an impact throughout the body and all different tissues. And then another key concept is sarcopenia that then leads to frailty. So frailty is like when they're severely fatigued, they really can't move, they have weight loss, they want to engage in any social activities, they're tired all the time. This is when they end up becoming scooter bound or wheelchair bound. To that point, their risk for mortality skyrockets. Their life expectancy drops significantly as soon as they become the classification of frailty. So, sarcopenia is when they lose muscle mass, frailty when they have significant impacts of these things. Now, obviously, the two major causes of this is lack of physical activity and not enough protein or not enough caloric intake. But hormonal imbalances, just systemic inflammation, any kind of underlying disease that impacts your metabolism can all play a role. But the first two you always want to go through is physical activity and adequate protein intake. So if you see like an elderly person and they have sarcopenia, they just don't have much muscle mass, they have weakness, first thing you want to do is go through and do a dietary history. Tell me what you're eating throughout the day. What you're looking for is that they're just eating some protein. Okay, you don't have to come up with a single calculation, but what you're going to see with them is just missed meals all the time. When they eat, they don't have much protein. And that would be the first place to definitely start. And then once you get some protein, especially if you don't have inflammation, if you get any kind of movement, especially strengthening exercises, you guys in the strengthening exercises could literally be hold on to something and squat and hold each, every few degrees up. Do that 10 times a day. Put your hands against the wall and just push off for a little bit because they can't even do a push-up yet. Maybe they just start with that and they start increasing their activity to what they can do. Of course, you got to be careful with falling issues with people that have sarcopenia, but it's a major cause of all-cause mortality. This was a study that was published, 57 studies. It was a review and meta-analysis, 42,000 subjects in this analysis. Sarcopenia is associated with significant higher risk of mortality, independent of population and sarcopenia definitions, which highlights the need for screening early diagnosis in all populations. If you're working with elderly patients, you're going to definitely want to check their muscle strength. We talk about the evaluation. We'll check for grip strength and different muscle fitness tests to evaluate risk for this. And then frailty syndrome, which is more severe, includes lower activity levels, poor exercise tolerance, and loss of lean body and muscle mass. Poor exercise tolerance is related to aerobic endurance. Resistance training is the best way to increase muscle strength and mass. Muscle strength, regardless of other factors such as metabolic syndrome, physical activity, and smoking, is predictive of longevity. Okay, so muscle strength, the actual strength of muscles, not VO2 max. Muscle strength, regardless of other factors such as metabolic syndrome, physical activity, and smoking, is predictive of longevity. So the more muscle strength they have, unrelated to if they're a smoker, they have obesity with metabolic syndrome, is the key factor. And even if they're not even physically active, the muscle strength itself is a key factor and predictor of longevity. So the other thing is you want to make sure you have muscle mass. You want to make sure things that are challenging to your muscular system. So you think of hormesis. When you do cardiovascular fitness, you get to the point where you're having a hard time breathing and you want to quit. So that's cardiovascular fitness. Muscle fitness is your muscles are burning, right? They have that burning feeling sensation doing some activity. Muscles are shaking. That's how you're building hormesis in those pathways. Those are really important to maintain longevity. Okay, this is a paper titled Muscle Mass Index, the Predictor of Longevity in Older Adults. And they go on to show in this review, muscle mass independent of fat mass and cardiovascular and metabolic risk factor is inversely associated with mortality risk in older adults. Okay? So it's its own very profound independent variable that impacts longevity. These findings suggest that anabolic processes that promote muscle bulk may be associated with longer survival. You cannot have muscles and have muscle mass unless you're in an anabolic state. Changes in body composition rather than adiposity alone should be considered with counseling older adults and preventive health behaviors. Now, when you look at muscle mass, when people are elderly, it becomes a big issue. And then with some people, like if you've been following the cases in the clinical mastership program, in the past year, we've had 2 females that were underweight. Wait, three We had 3 cases of underweight issues causing significant health problems for them. One was like an infertility case. One was severe cognitive decline, immune weakness, immune pathology. So remember, body fat contains adipocytes and adipokines that are functioning, so you don't want to be underweight. And then when you look at longevity, we have some cases in there of female patients that don't have muscle mass. I'm going to share a couple cases with you tomorrow, but it's its own risk factor. And to be quite honest, they're so progressed, I'm not sure if we can build muscle mass on them right now. So it's something to shoot for, but it's an important part of it. It's unrelated to any supplement. You just have to have muscle activity, strength, and exercises. Then you get into body mass index, and basically body mass index, severe underweight people have increased risk, and overweight people have increased risk. Normal weight's ideal. And body mass index is associated with an overall mortality, most specific cause of death for mental, behavioral, neurological. External causes, lower BMI associated with increased mortality risk. This is a study of 3.6 million adults in the UK. And look at what they found here. So let's say normal BMI, like if you look at normal BMI, 18.5 to 25. Which if you look at this database of 3.6 million people and look at their hazard ratios for all-cause mortality, the ones with the lowest risk were in that normal age group, right? But take a look at this. If you look at someone over here in the obese, severely obese range, and their risk, let's say 2.0 increased mortality risk, it's almost the same as someone who's underweight. So what that means is like this person that's underweight has the same risk for all-cause mortality as this person that's totally overweight. So those are things to take into account, because you definitely are going to, we tend to only focus on overweight patients when we look at physiology and health, because there's this like glorification of people being extremely thin for being healthy, which is absolutely not true. And it's a major concern for mortality, especially if they don't have any muscle strength. And then we also know when researchers look at body mass composition, BMI itself has its own limitations, because for example, there's 10% of people that are metabolically obese, but they're metabolically totally healthy. They don't have any insulin resistance issues. They don't have high blood pressure. They don't have any problems. And one of the main factors is also they have a lot of muscle mass. So this is like a obese person, abnormal BMI, but so healthy. Then we also have normal BMI people that are totally metabolic and healthy. Even though they're normal body weight, they have insulin resistance, they have lots of inflammation, they have cardiovascular risk. So you got to be careful just looking at BMI. And these are, again, let's say 10 and 8% of the population, but these are definitely in your practice to some degree, because they're not healthy. They're usually they get some kind of symptom or abnormality checked out. Okay, 26 prospective studies, review meta-analysis of effect of weight loss and all-cause mortality risk. Recently, a great emphasis has been placed on weight loss by lifestyle change for everyone who is even slightly overweight. However, a review of the available literature complemented by meta-analysis suggests that at-risk individuals may benefit. But for healthy overweight individuals, intentional weight loss does not decrease mortality and may even increase it. Appropriately designed intervention studies in subgroups differing by age, sex, and ethnic group, as well as by risk status, are urgently needed. The bottom line, just be healthy. Like the pushing of someone to get to 0% body fat and to get super, super fit looking may actually increase risk for mortality. So that's what this paper is warning. So interesting to see how the research is pointing out that way. Ultimately, normal body mass would be ideal. The more muscle you have, the better. The less body fat you have, the better. But you don't want to be extreme on any sides of those patterns. It doesn't make a big difference. When you get extreme, it can actually be harmful. Now, when you look at dietary interventions, there's dietary interventions for increasing longevity or increasing lifespan, and there's dietary interventions for improving wellness. Let's focus on the lifespan ones first. So, this was a paper that was published. It was a systematic review, dietary patterns of survival to 100 plus years, and they wrote an empty systematic review of cohort and case control studies. They reviewed 3,695 records, 108 studies. Consequently, there is no direct evidence currently exists on the association between dietary habits and late life and survival to 100 years. That doesn't mean dietary patterns don't change your aging and longevity. They're just saying there's no real data on it. No one has done studies where they track someone to see how centenarians eat versus other people. They kind of do retrospective, they kind of look at analysis. So there isn't necessarily a clear diet that will tell you this is the best way to eat. So there isn't like, you have to be a vegetarian to survive 100 years, or you have to be on a carnivore diet, or whatever the case may be. So there's going to be a high degree of uniqueness and different expressions that are going to be really important for us. This is this paper that was published called Dietary Patterns and the Healthy Aging Study, the Canadian Longitudinal Study of the Aging Cohort. So this is something to look at that does give us some ideas. They found that very few people live to 85 years and older. They call them in this study the oldest old. And even fewer live to this age without developing chronic disease. It's important to understand the relationship of any modifiable factors to diet and healthy aging. However, there are a few studies of diet among healthy old, especially in North American populations. We aim to characterize dietary patterns of super seniors in the Canadian Health Engage study. So basically, they're looking at people that are 85 years old that don't have disease yet. Okay? So looked at 122 super seniors, age 85 and older, free of cancer, cardiovascular disease, pulmonary disease, dementia, and diabetes. They were all recruited. Comparisons were made with those with 12,626 participants aged 65 to 86 in the Canadian Longitudinal Study of Aging who completed the same 36-item food frequency questionnaire and encouraged consumption over the prior 12 months of nutrients and food thought to be important for aging. Dietary patterns were identified with principal component analysis. The odds of being a super senior were determined from 4 quartiles of each dietary patterns with logistic regression. So they're now looking at 85-year-olds that have no disease, and what are they doing in comparison to the rest of the population? And then they found 2 dietary patterns were identified. A Western diet characterized by French fries, red meat, processed meat, and nutrient-rich diet, which included fruits, vegetables, whole grains, nuts, and seeds, among other healthy food choices. Right, so they have this nutrient-rich diet, Western diet. Higher scores for both dietary patterns were associated with increased odds of being a super senior. However, only the Western diet pattern remained associated with adjustments for covariates. Do you know what they're saying? They're saying the people who actually had the Western diet were the super seniors in this actual study. The Western diet, the French fries, the meat, the rich foods, they did better, especially when they adjusted for variables. Finding adds to limited evidence on dietary intake among the healthiest adults, but it is unclear whether association reflects generational differences between groups. So when you look at this, you have group 1 and group 2. One's the Western diet. Western diet, they have meat. The nutrient-rich diet, very little meat. Then you look at whole foods and snacky foods and fruits and vegetables, complete difference. And when you look at the Western diet, their odds of being like a super aged, healthy person without any disease was 2.06, but for the nutrient-rich diet, it was 1.75. And this was actually statistically significant. This wasn't, especially when they adjusted for smoking status, household income, education, marital status, sex, body mass composition. They still found this to be much more impactful. So what does that tell you? It tells you a couple things. Like, one is there's a lot of controversy in diets and longevity medicine. Now, if you took a group, now this was like compared to the general population, if you took a group of people that had cardiovascular disease and you put them on high inflammatory foods and fried foods, studies have already shown that that does increase risk. So this wasn't disease-based population. This was just like general population. But what you're finding is these individuals that are 88 years old with no disease, they didn't go into any kind of extreme dietary change where they were only eating a plant-based diet or only eating red meat or anything like that. They were just, basically eating foods that most people eat. So it's really maybe not as much food type as caloric intake, because caloric intake definitely has an impact, but the food choices people pick may not be overall as determining risk. Now, obviously, people that even on the Western diet in the study are still getting basic micronutrients in. They're not like micronutrient deficient. They're just not as perfect and as ideal as the other diet. In conclusion, results suggest the Western diet patterns associated with increased odds of healthy aging in the sample of older Canadian adults. This finding adds to the limited evidence base of dietary intake among the healthiest oldest, but its implications should be considered in the context of possible generational differences in diet and limitations of the assessment of food and nutrient frequency, but not the amount of food. Now, again, these are generalizable studies for large populations. In real clinical settings, we're not dealing with general populations. We're dealing with specific diseases, specific cases. You're going to have to make different interventions based on the condition and how a person responds to and their inflammation and their individual markers. And that's the way it works. But when you hear people say, there's no specific food type diet that impacts longevity, that's a true statement in the research that's available for that. But it doesn't mean that food doesn't cause changes in longevity genes and inflammation and expressions for individual cases and individual diseases. It's just a general statement of that. Okay, overall, when you look at food, it doesn't matter if you eat more Western foods or more plant-based foods. It seems like in long-term studies, it really has to do with the caloric restriction, because caloric restriction has been found to have profound benefits. And caloric restriction could be time-restricted feeding, where there's a fasting physiology phase in between them, or it could be just doing some extended fast to really preserve life and turn on these genetic genes, or causing that hormesis response. So whether it's if we look at the Western diet, more of the plant-based diet, the caloric intakes were pretty much similar for what they needed to function. The food choices themselves didn't seem to be the key variable, but the time periods between eating and caloric restriction physiology maybe were the main differences. So the health benefits of chronic caloric restriction resulting in lifespan extension are well established in many species, and has been recently demonstrated also in non-human primates, but also effects on human remain to be proven on a long-term basis. So basically saying caloric restriction is definitely showing impacts in non-humans, and in humans, we're just waiting to get more and more studies. But it's clear that it is having effects on various diseases. It's just this hard to measure longevity because it takes so much time. And again, the thing with caloric restriction is an impact on the mTOR pathway, AMPK, sirtuin pathways, that all seem to change when people go on time-restricted feeding or dietary time-restricted feeding and so forth. Okay, so that's where longevity medicine has really placed most of its focus on. And when you take a look at dietary restrictions and disease of aging altogether, so dietary restrictions have been shown to impact body weight, body fat, insulin sensitivity, inflammation, which for sure impact cardiovascular disease, decreased atherosclerosis, decreased cholesterol levels. So they definitely impact diseases itself, but there isn't any clear direct link between lifespan overall, meaning there's no foods you eat that increase your lifespan. So lifespan gene expression is going to be from restriction. So here's a summary of the current research. There's no specific diet that increases lifespan. Okay? Caloric restriction has a clear impact on animal studies in increasing longevity. The study design has limited impact on human studies. There is clear indication that caloric restriction can have significant positive health impacts on humans, and it seems that animal research may be translatable into human responses. I believe it is. Caloric restriction diets must be juggled with concerns for a lack of protein and calories that are of concern with elderly patients, especially if they have frailty. So that's the balance you have to think about in clinical implications. Can they do a caloric restriction diet, or are they going to lose severe muscle mass? Or are they already underweight and can't do it? Those are those things you have to factor in. Okay, let's go into some other parts of this, which is looking at foods. This was the paper that was titled High Dietary Diversity Scores in Protein-Rich Foods Consumption were associated with lower risk of all-cause disease. Method. The study included 28,790 participants, age 80 plus and older, and 9,925 9-year-olds and 9,000 centenarians. A food questionnaire was used to evaluate diet. What they found was protein-rich items were associated with prominent beneficial effects on mortality, including meat, fish, seafood, eggs, and beans. So just another key concern of like when people are focused on caloric restriction, they got to make sure that they don't become nutrient deficient. Macronutrient deficient would be not enough proteins, okay? Now, those are all the studies on longevity, but then we got to talk about wellness. When you talk about wellness, meaning not having disease, there are direct links to diet and wellness. And obviously the most important connection is cardiovascular disease. So key concepts. Since cardiovascular disease is the leading cause of death worldwide, diets are focused on reducing morbidity, emphasize a cardioprotective diet. Now, in the Crosby Institute cardiovascular course, we went through the literature on every single type of diet that's been published in cardiovascular disease. And in a real clinical setting, in a functional medicine model, we have to do personalized models to how we want to treat the patient. Like if they have kidney disease, we might want to do a DASH diet. If they have an autoimmune disease, we want to be careful with doing, we might want to do an autoimmune paleo diet. Right. Some people have to do a caffeine restricted diet. They have their blood pressure go up like crazy because they're high metabolizers genetically. So the way we went through it in the cardiovascular course, which I want to share with you here, is really depends on what your dietary goals are when you're trying to choose a diet. And when you're trying to choose a diet, not based on caloric intake, but based on the patient's physiology and what kind of conditions they have, you want to really think about what your goals are, okay? Because any one of these diets may be appropriate for a patient where you're trying to improve their longevity. And since cardiovascular disease and cancer almost have similar diet risks, if you're trying to pick a diet, you want to pick one that really works with the cardiovascular risk markers. That'd be like their HbA1c levels, their fasting insulin levels, their inflammatory markers. Like if a diet makes their lipid markers go up and their lipid particle size markers go up and become abnormal, and their HbA1c goes up and their ferritin goes up and C-reactive protein goes up, it's terrible for them. And if their symptoms get worse, it's terrible for them. But if they change their diet, then it make a difference for them. I guess, and for some people, it's going to be like a carnivore diet. For some people, they can't get their symptoms under control until they just go on a carnivore diet, which completely doesn't make sense to anything when you are focused on the microbiome because of our understandings are limited at this point, but it worked for some people. And some people just do better on a plant-based diet and their physiology changes. And if you remember, like a third of the microbiome is genetically based, and it's maybe those third of genes that are genetically based that may make a person more responsive to one diet or another. So for example, people that were Eskimos, they have genetic Eskimo genes where they hunted seals all day and didn't have a lot of fibers and plants to eat. And they may do better when they go on more of a carnivore type diet. Or even some Nordic region genes that were just hunters and basically ate animals and had very little fruit and vegetables seem to do better on diets like that. We don't know. We're still learning about it. But ultimately, when you look at diets, you could have, you could look at the reducing insulin, like cardiometabolic diet, Mediterranean diet, ketogenic diet. They may all reduce insulin. Mediterranean diet being the most popular for cardioprotection, longevity, because the most common cause of death is heart disease. And Mediterranean diets seem to impact heart disease. Obviously, that's going to be the generalizable diet for most people to follow. But some people can't follow Mediterranean diet because Mediterranean diet is an issue with them because they have autoimmune disease and it's filled with lectins. And they can't eat beans and tomatoes and all the things in a Mediterranean diet because it's an issue with them. Some people may not be able to eat the fishes in a Mediterranean diet because they have high TMAO levels. And the TMAO levels may cause severe inflammatory stress to the endothelium. So it depends on, are you trying to do weight loss, you're trying to reduce blood pressure, trying to reduce food antigens, reduce TMAO, you're trying to reduce inflammation. And ultimately, in real practices, people do a combination of various things. So they may have one patient, they go, hey, we're going to have you on a ketogenic diet, but you can't do gluten dairy because you react against them. We want your diet to be as microbiome diverse as possible. Another person could come in and say, you need you on a DASH diet. We got to get your sodium down. got to get you in ketosis, and you got to follow autoimmune paleo diet. Another person, vegetarian, but fish is allowed. They may need to be on a high-fat diet. So, you experiment. And in reality, there isn't a generalizable diet for real patients. You have to figure out what they want to do. So here's, some examples. If you had an obese, hypertensive patient with an elevated calcium coronary artery score, fasting glucose was high, LDL was high, HDL was high, CRP was high, which kind of diet would you choose? We definitely want to choose something that reduces their insulin levels. So you may immediately want to go to reducing insulin, whether you choose ketogenic or Mediterranean. That's up to you. Maybe you go completely vegetarian for a while. So these all really make a difference on what your goals are. If someone's underweight, hypotensive, had RA and possible lupus, and had cardiovascular risk markers, you probably want to make sure they can increase their caloric intake and not eat foods that are going to trigger their autoimmune disease. So, a higher fat diet may be appropriate for them without lots of gluten and dairy and lectins and so forth. But that's the concept as you go through these different patterns. Now, let's talk about tobacco use. Let's make it really simple. It's not good for you. So tobacco use is just linked to higher death rates, higher mortality. The more tobacco use that a person has, the greater risk they have for lung cancer, which is the leading cause of cancer. And secondhand smoke tends to be a major issue. So even when someone starts smoking at old ages, that tends to be a problem. Now, I will tell you, there's debate in the world of cigarette and cigar worlds where they're saying, well, cigarettes have all the filters and that's what's really toxic, and cigars don't. And there's actually one, like cigar scientists, they reference a paper where they showed you have to have more than 4 cigars per day to have cardiovascular risk. And they go, and that study wasn't even perfect because they used grocery store cigars. And you don't inhale as much. And they said, well, cigarettes for sure are bad, but cigars are not as bad. And they would quote that one study. But in general, it's just not good. It's smoke, okay? It's a free radical. So excessive amounts of free radicals are an issue. And if you're using filters with cigarette, it's really bad. So that's the key symbol there. So alcohol, that's very easy. Alcohol use is a little bit more complicated, not more complicated, but good news with alcohol, you can drink alcohol and still be healthy. Okay. So this was a study that was done called Do Moderate Drinkers Have Reduced Mortality Risk? Systematic Review and Analysis of Alcohol Consumption, All-Cause Mortality. And in our summary, our study suggests that a skeptical position is warranted in relation to evidence. Low volume consumption up to 2 drinks is associated with net health benefits. So in this study where they looked at, you can look at nearly 4 million subjects, all-cause mortality, found those that actually had, some alcohol were okay. May even had some benefits. So that's it. And they didn't do like resveratrol in wine, or it was just the alcohol content itself. And then this was another study they did, the association of timeline alcohol use with mortality and cancer risk in older adults, cohort study, 8.9 median follow-up year, almost 100,000 patients. The study supports a J-shaped association between alcohol and mortality in older adults, which remains after adjustments for cancer risk. These results indicate that intakes between 1 and less than 5 drinks per week were associated with the lowest combined risk of cancer and death. So again, you don't have to be completely off all alcohol to live longer. And maybe there's some benefits there. Now, some other researchers looked at benefits of alcohol drinkers that are not alcoholics, but just have a drink here or there. And the key feature with them is they're also social. And they have drinks usually when they're around friends and family, and they're talking. They're not alone in the dark drinking by themselves. So that's the main confounder that people have to look at when they look at these alcohol studies. Because usually when people drink throughout the week, it's always in a social setting. It's rarely alone in the dark, alone. Okay. In conclusion, this is another paper looking at close to 600,000 subjects. In conclusion, our study shows that among current drinkers, the threshold for lower risk of all-cause mortality was about 100 grams per week. For cardiovascular disease subtypes other than myocardial infarction, there were no clear thresholds below low alcohol consumption. There was no clear thresholds below which lower alcohol consumption stopped being associated with lower risk of disease risk. The data did support lower limits of alcohol consumption than are recommended in most current guidelines. So if you look at the guidelines of 100 grams per week, so that's like, let's say, a drink a day or about a drink a day or less than a drink a day. The all-cause mortality wasn't too bad. But listen, if you're an alcoholic, you're going to have serious problems. So really, the more alcohol a person drinks, they're going to have problems. So the casual drinker isn't an issue, but if you're drinking, more than a couple of drinks a day on a regular basis, that's going to cause health problems, one of them being liver disease, liver cirrhosis, alcohol-related liver cirrhosis, okay? And then when you look at cardiovascular risk outcomes, it's pretty clear that alcohol risk does go up. So for people that do drink, if you have cardiovascular disease, it is much more sensitive. So 100 grams per week, you may not be able to really tolerate that 1 to 2 drinks per day if you have risk for stroke or ischemic disease or heart attack. So you got to look at these studies at longevity and go, are they generalized by the whole population? But when you start looking at disease bases, there's different risks that are involved. Obviously, someone with hepatitis can't handle 1 or 2 drinks a day, even though the general population can, right? This was a study called Alcohol Intake, Cognitive Health, Longevity, Community Dwelling Adults, Rancho Bernardo study, 1,300 subjects from 1984 to 2009. Near daily drinkers, meaning they almost had a drink almost every day, but had a 2 to 3-fold higher adjusted odds of cognitive healthy longevity versus living at least to age 85 with cognitive impairment or death before 85. Although excessive drinking has negative health consequences, these results suggest that regular, moderate drinking may play a role in cognitive healthy longevity. So, study after study of all different sizes, all different lengths show you're not going to have your longevity impact in a negative way for having 1 or 2 drinks daily throughout the week. Now, daily is still a lot. But some people have a glass of wine here or there. It doesn't seem to be an issue. Now, what they have found, like volume does matter. If you have a lot of alcohol, you're an alcoholic, you definitely have liver disease rates go up, cancer risks go up, infectious disease rates go up. Or, here's the other one, if you're a heavy drinker. So if you say, well, you can have 2 drinks 2 drinks a day, and I'm going to have them all on Friday night. That's called heavy drinking occasions. Heavy drinking occasioners do have increased risk, especially for heart attack, especially for injury because they're falling and hurting themselves because they're so drunk. So there's a big difference between like having 5 drinks throughout the week between 5 drinks all in one night. So heavy drinking occasions are not good. They do increase risk for heart attack, ischemic heart disease, in those people. So that's alcohol use. Environmental toxins. Bottom line, they're bad, right? We all know that. The results suggest that poor environmental quality, particularly poor air quality, is associated with increased mortality. Associations vary on urbanicity and climate regions. And every single toxin you can think of is associated with decreasing mortality, all these things. These are just all the things in the air. These are all emissions that are in the air. And basically, they look at studies. The more exposure you get, the more risk you have. And then when they look at ambient air pollution or household air pollution or proximity to traffic, proximity to health services, social, economic environment, density of the population, nighttime light land use, all those things, they increase greater pollution. Greater pollution increases risk for all diseases. And that's not a surprise to anyone. Recent publications strengthen the evidence for adverse effects of ambient air pollutants, exposure, and type 2 diabetes. Lots of strong links between cancer and diabetes with pollution. So air pollution tends to be a big one with them. They also found relationships with other things. Now, this is one on sunlight. So this review has identified a small body of evidence that suggests sun exposure protects against blood pressure and CVD. Because one of the key things is that dermatologists all hate sunlight, but other people love sunlight. So they actually found in this study sunlight was useful, even though some people consider it an environmental trigger. And then ultimately, this is one of my papers that I would recommend you take a look at when you look at this topic of environmental disease. And this paper was titled Known and Unknowns of Burden Disease Due to Chemicals, a Systematic Review. And this is what he goes on to say. He goes, the known burden to chemicals is considerable. The information supports decision-making in programs having a role to play in reducing human exposure to toxic chemicals. These figures present only a number of chemicals for which data is available. Therefore, they are more likely underestimated the actual burden. Chemicals with known health effects such as dioxin, cadmium, mercury, and chronic exposure to pesticides, cannot be included in this article due to incomplete data information. They're just not collecting data on how pesticides and mercury and amalgam fillings and all these different things can impact longevity. So in this paper, it goes on to say it's without doubt that they cause health problems, but we just can't do anything about it. And this, this is something that we all know, but this is really more for health policy. What are we going to do to change ambient air quality with where our patient lives? We can't. All we can do is try to get air quality in their house better, like with an air filter, try to have them decrease the chemical load with things that they can. And if you look at the sources of everyday toxic chemical exposures, outdoor air, indoor air, drinking water, food, soil, occupational exposure, human, these are the three main things we can focus on. And we're going to focus on these when we get into a treatment application for longevity. Indoor air, drinking water, and food. And food containers in particular, and how food is cooked. Those are the three things that can easily be changed to totally reduce chemical load with the person and reduce health risk. And here's the question I have for you guys that are listening. Have you actually gone into a strategy to reduce your home's toxic load? You should be doing that. You should rip out all your carpet. You should use wooden floors. You should get rid of fire retardant furniture. You should switch everything from plastics to glass and aluminum. You got to look at your cleaning products, all that stuff. You need to make a week out of your schedule somewhere and really focus on putting some efforts into changing your environment, because those things do have an impact on your toxic load and genotoxicity and telomere shortening. And especially if you do it now when you have 5 years of less exposure, 10 years of less exposure, 15 years of exposure, it can have a profound impact. Now, in this paper that really discussed how important these unknown sources are, they kind of showed acute poisoning. So people focus on diseases caused by high levels of chronic exposure, people working at work environments. And then as you go further down, physiological change and uncertain symptoms of body burden is less frequently observed, but this is really where you may have the biggest problem. There just isn't a lot of investigation and research there. And ultimately, all these different chemical exposures, they damage DNA, and then the goal is to try to repair them. Now, another major area of lifestyle factor concern is polypharmacy. Multiple drugs, 3 or more drugs, polypharmacy. 47 studies, meta-analysis. Pool estimates for the risk of meta-analysis reveal that polypharmacy is associated with increased mortality risk using both discrete and categorical definitions. The causalities of these relationships remain unclear, but emphasize the need for approaches to health care delivery and balance between risk and benefit taking medications. And there's paper after paper. I'm not going to read them all to you as we're finishing up the time here, but there were multiple meta-analyses, long-term studies, big population cohorts, and it's simple. If you're in polypharmacy, your risk for survival goes down, your longevity goes down. And if you read the tone of these papers with polypharmacy, they're basically saying, what are you guys doing? That's how the tone of these papers are. What are you physicians, healthcare people doing? Don't you understand that there's risk with all these drugs? And you can literally look at someone's amount of medication they're taking and then look at their lifespan and shorten it. Now you could say, well, they're so sick, that's why they need all the drugs, that's why. But really? Because when we look at populations that have the same degree of illness without all those drugs, they don't have the same loss of longevity. So, more drugs, the worse they are. And myself, in my practice, if I see polypharmacy, I don't even work with them, because I don't want to. I can only take so many patients per year. If I see someone on 5 or 6 drugs, I'm not the person for you. You're in a different model, and I don't work in that model. Social relationships, another major one. This is pretty obvious, but really they found social relationships have a huge impact on longevity and health. This was a study of 300,000 plus subjects. They followed them for 7.5 years. And they found that indicate individuals with adequate social relationships have a 50% greater likelihood of survival compared to those with poor and insufficient social relationships when faced with the disease. The magnitude of this effect is comparable with quitting smoking, and it exceeds many well-known risk factors like obesity and physical inactivity. So if you have healthy social relationships, the magnitude of the effect on all-cause mortality is like you quit smoking or you're no longer obese. It's really, really profound. Okay. So if you look at the study here, comparison of voluntary decrease mortality across 7 conditions, social relationships, at various times, you can see social, like here's the BMI lean versus obese. You can see the difference risk. Here's social relationships, overall findings, high versus low social support contrasted. Look at the effect size difference between that and lean versus obese. Air pollution, low versus high. Physical activity. So social relationships are like way up there. So if you want to have longevity, you have to have social relationships. You got to find a way to be social. If you're not social, it's going to have a direct impact on your health and your mortality, your survival rate when you're faced with the disease. Another key one, the sense of purpose. Numerous studies have really shown sense of purpose is a huge factor in all-cause mortality. This was a large study that was published in JAMA Network. 7,000 subjects followed from 1990 to 2018. And they actually looked at how purposeful how strong their sense of purpose was, and they looked at survival probability and survival death, and they basically found the ones that had the highest sense of purpose in life are the ones that had the greatest longevity and the least amount of all-cause mortality. That's really important. So be passionate about what they do, passionate what they want to do in life makes a big difference. If you lose your purpose in life and you don't know what that is, that's not a good sign. If you're not social, that's not a good sign. Even these things are even more profound than quitting smoking or obesity. The highest level of purpose appeared to be protective against all-cause mortality regardless of level of socioeconomic status. And then we found, another paper, found that in men having a sense of purpose in life, affected risk of death as a result of causing a stroke of all causes, stroke and CVD, and many papers show the same thing. So those were the summary of the main concepts that we went over, and we'll talk about these more when we talk about clinical application, developing a treatment plan. Thank you.